Imagine waking up in 2026 to news no one expected. Tesla has just abandoned lithium. That's right, the technological foundation that underpinned the electric vehicle revolution for the past 20 years is a thing of the past. In its place, Elon Musk surprised the world by revealing that Tesla is betting everything on an aluminum-ion battery. And it wasn't an impulsive decision. This transition has been built behind the scenes for years, away from the spotlight and memes about the Cybertruck, while the rest of the world was still debating the future of lithium. The most curious detail? This new battery won't debut in a top-of-the-line model. It will go straight to the brand's most affordable car, the Model 2. While the market chased after lithium as if it were gold, Tesla decided to follow a nearly unexplored path. Aluminum, abundant and cheap, emerged as a more strategic alternative, not only in terms of cost, but mainly in terms of independence. It's a masterstroke against geopolitical constraints. After all, lithium is concentrated in a few countries, and trade tensions continue to rise. And aluminum? It's widely distributed and easy to recycle. It's as if Elon were saying, "We're not going to depend on anyone anymore." But the rabbit hole goes deeper. Tesla's big secret lies in removing critical materials like cobalt, nickel, and manganese, those that cause environmental and ethical nightmares. Cobalt, for example, is a serious problem. Its price fluctuates wildly, and much of its production comes from areas where extraction involves child labor. Replacing it with aluminum completely changes the game. And Musk knows this. He's not just changing the technology, but challenging the entire structure behind the global supply chain. With this change, Tesla is also repositioning itself politically. By getting rid of lithium, the company cuts one of its biggest dependencies on China. This isn't just a business matter, it's a chess move on an international scale. Now, with aluminum coming from countries like Australia, India, and even the US itself, Tesla reinforces its presence in American territory and fits perfectly within the government's tax incentives. Pure strategy. The question that arises is, why only now? The answer may lie in what Elon Musk has always done best, working quietly while everyone else is looking the wrong way. While the public was distracted by the dancing Tesla bot or Cybertruck deliveries, Tesla's engineering team was immersed in advanced research, closing discrete deals, acquiring key startups, and secretly testing prototypes. This explains how the company managed to present such a radical technology with such a high degree of maturity. And if you're thinking this change might be risky, just remember who we're analyzing. Tesla isn't just a car manufacturer. It's a global-scale laboratory. When it decides to replace a core technology like lithium, it's because it has already tested, stressed, and validated every component of the new architecture. That's precisely why the debut will be in the most anticipated car of the decade, the Model 2, and not in an unattainable futuristic concept. While everyone was still digesting the news of the shift to aluminum, another detail began to draw attention: the source of this raw material. Aluminum currently costs around $2,200 per ton, while cobalt can reach $80,000. The difference is absurd, and even more shocking is knowing that aluminum is present in more than 40 countries. This completely changes the logic of market dependence. Where lithium requires concentrated and unstable mining, aluminum offers a decentralized global network, with suppliers in Asia, America, Europe, and practically anywhere there is industrial infrastructure. And that's where a masterstroke that few have noticed comes in. India, China, and Australia lead the world in aluminum production. But unlike lithium, this market isn't in the hands of just 2 or 3 players. The distribution is more balanced, and this gives Tesla a brutal advantage when negotiating contracts, diversifying sources, and avoiding crises like the one that hit the lithium supply chain in recent years. For a company that wants to produce millions of affordable vehicles, this is simply vital. But it's not just a matter of geopolitics. It's also about sustainability. Recycled aluminum consumes only 5% of the energy that would be spent extracting the raw metal. In times when all companies are rushing to show their green credentials, this detail is invaluable. Imagine producing an almost entire battery from recycled aluminum, with minimal energy consumption, without the use of toxic products, and with greater durability. This is not only good for the planet, it's excellent for business. And as if that weren't enough, the aluminum recycling process is already extremely efficient. Unlike lithium batteries, which require expensive methods, corrosive acids, and extremely high temperatures for reuse, aluminum can be recycled using simple mechanical processes with far less waste. This reduces costs, accelerates reuse, and virtually eliminates the risk of large-scale pollution. It seems like something out of this world, but it's just aluminum being put to good use. Tesla also saves time in this endeavor. Instead of waiting for the construction of new lithium mines, a process that can take 5 to 10 years, the company can already operate with suppliers who have tons of lithium ready for use. And we're not talking about impossible contracts. We're talking about a raw material that already supplies the aeronautical, food, construction, and even household appliance industries. In other words, the infrastructure already exists. It just needs to be redirected. Another interesting point is the impact on the final cost of the car. With the price of aluminum so much more accessible and the manufacturing process simpler, Tesla can finally deliver a truly inexpensive electric car. Not only cheaper than a Corolla, but cheaper than many popular cars in Brazil, India, or Indonesia. It's a historic breakthrough. That dream of an EV for everyone is finally starting to become a reality. While affordability and sustainability already put aluminum in the lead, another factor is starting to steal the spotlight: safety. Anyone who has researched lithium batteries knows they can be temperamental. Accidents involving overheating, spontaneous fires, or explosions are still a real problem in certain contexts, but with the new aluminum-ion batteries, this fear seems to be numbered. The key lies in the type of electrolyte used. Instead of volatile and flammable compounds, Tesla opted for stable ionic liquids that do not catch fire even under extreme stress. Recent tests, such as those conducted at Stanford, show almost unbelievable scenes. Aluminum cells were pierced with steel needles, crushed by hydraulic presses, and even deliberately short-circuited. And the result? No sparks, no smoke, no abnormal heat. This thermal stability is something that lithium has not yet achieved, even after decades of development. Now imagine putting this in cars traveling under scorching sun, on busy highways, or even in remote and icy regions. And speaking of extreme climates, the new battery is practically a chameleon. It operates with stable performance from 50 degrees C to 85 degrees C, without needing complex heating or cooling systems. This changes everything for countries like Canada, Russia, India, and Brazil, where temperature variations are brutal from one region to another. With this battery, the owner of a Tesla Model 2 in Alaska will have the same confidence as someone driving in the Arizona desert. This thermal resistance isn't just a matter of comfort. It increases the lifespan of components, reduces the risk of unexpected failures, and eliminates the need for certain thermal management systems. This means fewer parts, less maintenance, and, of course, lower costs for the consumer. And the most incredible part is that all this is achieved without compromising performance. On the contrary, the new battery is also surprising in performance tests. Of course, a safer battery is also a victory in terms of image. In times where every failure goes viral on social media in a matter of minutes, offering a solution that literally doesn't catch fire can become a huge competitive advantage. And if anyone was still afraid to leave their car charging overnight, that fear is about to become a thing of the past. Another important point is user confidence. Many people who still hesitate to switch to electric cars have a subconscious fear of malfunctions or risks that don't exist in combustion engine cars. By eliminating this type of concern, Tesla is building not only a product, but a relationship of trust with the average consumer, the one who doesn't understand voltage, cycles, or electrolytes, but who wants to feel safe with the family car. If the safety is already surprising, the performance of these aluminum-ion batteries borders on the unbelievable. While the debate continues about which supercharger is the fastest, Tesla is already testing prototypes that reach peak charging speeds above 1,000 kWh. That's right, more than 1 megawatt. For those accustomed to the current 250 kW of the V3 superchargers, this difference is absurd. And the direct consequence of this? A fully charged electric car in less than 5 minutes. We are no longer talking about electric cars as the future. We are talking about something that directly competes with refueling a gasoline car in real time. In vehicles with smaller batteries, such as the Model 2, this time drops even further. Data indicates that, with packs between 40 and 50 kWh, a full recharge can be done in 3 to 4 minutes. This changes everything. The old argument that electric cars take too long to charge completely falls apart. That image of people waiting in a shopping mall parking lot or sleeping in their car while charging simply ceases to make sense. With the right technology, the process is as fast as an espresso. Now, imagine that speed combined with the daily routine. People going to work, delivery drivers, ride-sharing drivers, everyone stopping for a few minutes and continuing their journey as if nothing had happened. This solves, at once, two of the biggest obstacles to the mass adoption of EVs: the fear of waiting and the so-called range anxiety. Tesla is not only eliminating the problems, it's replacing the concept with something better. But speed didn't come alone. Durability also takes a giant leap. While traditional lithium batteries begin to show signs of wear between 1,000 and 3,000 cycles, tests with aluminum-ion batteries indicate up to 12,000 complete cycles without significant loss of capacity. Converted to the practical use of an average driver, this represents more than 2.5 million kilometers of road. For many people, this means the battery will last longer than the car itself. This is where things get even more interesting. This incredible durability not only increases resale value, but also shakes up the business model of automakers. Imagine selling a car with a lifetime battery warranty. Imagine buying an electric car and never having to think about replacing it again. This reduces costs for the consumer, improves brand reputation, and opens up space for new financing and leasing models based on real longevity, not optimistic estimates. And the benefits extend to larger sectors. Transport fleets, electric trucks, autonomous taxis, all can operate with minimal maintenance and almost zero charging time. This could completely transform the logistics sector in just a few years. Furthermore, it's not an exaggeration to imagine that this durability could allow for the creation of modular vehicles with parts that can be upgraded over time and a virtually permanent energy source. And when it comes to energy, size really matters. The energy density of these new batteries is another game changer. Thanks to the application of advanced materials like graphene in 3D structures, especially the so-called graphene foam, Tesla engineers have achieved something impressive. Aluminum-ion batteries that reach 1,350 watt per liter. To compare, the best lithium batteries today barely exceed 900 watt-hour. This means that, with less volume, Tesla can store more energy, and this opens doors to completely rethinking car design. And it's not just a matter of fitting more range into a smaller space. By reducing the size of the battery pack while maintaining the same capacity, internal space is freed up for other improvements. It's possible to increase structural safety, create larger trunks, expand legroom in the rear seats, or even make cars lower and more aerodynamic. It's a game of creative freedom for designers. And all this without compromising range, performance, or comfort. In fact, the car's structure itself can benefit from this increase in volume. Furthermore, the architecture used in these new batteries is of the soft pack type, meaning that the cells are flexible, thin, and adaptable to different shapes. While traditional 2170 or 4680 cells are cylindrical and require a certain amount of space, these new ones can be molded around irregular surfaces, fitted under the floor, embedded in doors, or even inside seats. We are talking about cells with a thickness of 4 mm, something almost surreal for most current automakers. And that's where a strategic advantage that few companies have comes in. Tesla doesn't depend on third parties to design its cars around batteries. It can develop everything in an integrated way, chassis, interior, electronics, and battery, as if it were a single organism. This allows it to fit these flexible cells where other automakers wouldn't even imagine, making the cars more efficient, lighter, and easier to assemble. And let's face it, Musk loves this kind of solution that seems straight out of a science fiction movie. And speaking of weight, this new generation of batteries can be up to 30% lighter than lithium batteries. Anyone who follows the world of electric vehicles knows that weight influences everything: acceleration, range, fuel consumption, and even the driving experience. With lighter cars, Tesla can deliver better performance with less effort, meaning more kilometers per kWh, less tire wear, and an even more environmentally friendly footprint. Another direct impact of high energy density is the reduction in the number of fuel cells needed. Instead of 4,000 or 6,000 cells, as in many current models, it's possible to achieve the same results with far fewer units. This simplifies production, reduces defects, and speeds up vehicle assembly. And if assembly is faster, the final cost of the car also drops. It's a domino effect of efficiency. If all this revolution in design already seems surprising, wait until you understand what Tesla is doing with the recycling of these batteries. Unlike the grueling process used with lithium, which requires harsh chemicals, extreme heat, and generates toxic waste, the new method adopted for aluminum-ion cells is much cleaner and more direct. It's a system called dry chemical, which uses pressure, vibration, and magnetic fields to mechanically separate the materials. And all this without using a drop of acid. This advancement isn't just good for the planet, it's a real relief for the company's finances. The cost of recycling with this dry system can be up to 40% lower compared to current methods. And when you consider millions of batteries circulating around the world, this saving translates into billions of dollars over the years. It's another area where Tesla is clearly planning for the future, producing at scale without inheriting the sustainability problems that are so often criticized in other automakers. Another point that makes this even more strategic is that, because they don't contain lithium, Tesla's aluminum batteries escape several limitations and regulations associated with the lithium supply chain. This not only eliminates the need to negotiate with controlled markets, but also frees Tesla from geopolitical risks related to mining in unstable areas, such as the classic case of the Democratic Republic of Congo in the supply of cobalt. And there's more. By excluding lithium from its equation, Tesla easily qualifies for incentives under the United States Inflation Reduction Act, IRA. This means each vehicle equipped with these batteries can receive up to $7,500 in tax credits, making all the difference in the final price to the consumer. In other words, Tesla can deliver a cleaner, more efficient, and even cheaper car, all within the law and with government support. This independence is, in practice, a golden ticket.